In this tutorial, I'm going to look at the one-sample t-test. The one-sample t-test is a statistical hypothesis test that is used to determine whether an unknown population mean is different from a hypothetical value. And we use the t-test when the sample is from a normal population. So the first thing that you need to do is to check if the sample that you have is normally distributed. And to do this, you can use a QQ plot, or you can use the Shapiro-Wilk test. But in this case, I'll go on straight and look at the problem which is appearing on the top there. We are having that sample there with the observations 44, 46, 62, 30, and so on. And we want to test the null hypothesis that mu is equals to 50, and the alternative hypothesis mu not equals to 50. So I'll start by entering that sample there that we have, and I'll call it x. So I will have my x there in the console, type x is equals to, and then the c, open parenthesis, and then type in those observations. So it will be 44, and then a comma, 46, comma, 62, and then a 30, a 75, a 102, a 48, a 74, an 85, and then a 66. And then I press enter. So I've entered the sample there. And now to perform the t-test, we use the command t.test. T.test, and we are testing the sample x, and we are testing the null hypothesis that mu is equal to 50. So we specify mu equals to 50. So with this command there, it will perform the one sample t-test. If you don't specify the alternative, then it will take it as the two-sided one. And in this case, we are testing the two-sided one where we have mu not equal to 50. So we can just leave the command for the alternative, because by default, if you leave it, then it calculates the two-sided one. And for the confidence interval, it will calculate the 95% confidence interval if you don't specify the confidence level here. So I'll press enter, and we have the result there. The test statistic is 1.9223, and we are having a p-value of 0.08673. So what we are seeing there is that p-value there is greater than 0.05. So in this case, we fail to reject H0. And when we fail to reject H0, we conclude that the mean is not significantly different from 50. So that's the result there of the t-test. But let me look at the other options. I said we can change the confidence level so that it calculates the 99% confidence interval. So I'll just press the up arrow and bring the command that I had entered before. And I want to change here the confidence level. So I'll say confidence level, conf.level, then change it to 0.99. In this case, it will calculate the 99% confidence interval. So as you can see now, it's calculating the 99% confidence interval. So that's how you change from the 95% to the 99%. Then another issue that I mentioned was that when I entered this command, this t-test x mu equals to 50, I said by default, if you don't specify the alternative hypothesis, it calculates the two-sided one, which is the one that we wanted for the problem that we had. But if you have a problem where you have the alternative being the less than one, then you would have to specify the alternative. So what you do is you type in alternative inside that after the mu there, alternative, the command there, alternative, then C, then open parenthesis, and then open quotation mark, then say less. So this one will do the alternative hypothesis where we have a mu less than 50. So if I press enter there, and it's giving us the alternative hypothesis there is saying the true mean is less than 50. But in this case, our p-value is 0.9566, which is greater than 0.05. In this case, we fail to reject H naught, and we again conclude that the mean is not significantly different from 50. But I was just illustrating if you want to change the alternative hypothesis. And if you want to have the alternative hypothesis for the greater than, then you just specify that it is greater. Then you to have the alternative hypothesis there is a greater than. So those are options for the t-test. You set your mu, the alternative, less than or greater. But if you don't specify the alternative there, it will just do the two-sided one. The mu not equals to the hypothetical value. And if you don't specify the confidence level, it will just take it as the 95%.